So I've been slacking off on my video making lately, and here I am again making videos about diamonds. And these are there's a bunch of them in there, little cubes, right? Everybody thinks the stuff is quartz, right? Except quartz does not form in cubes. Doesn't form cubes. Can't form cubes. Even stuff like this. This is tiger eye, right? Tiger eye. But it comes in little cubes, you guys, and quartz cannot and does not make cubes. Neither does opal. Blue opal, like from here in Arizona. It's not opal. It's 10 on the Mohs scale of hardness, like diamonds. And I do actually know a little bit about diamonds. First of all, they don't all come from the De Beers monopoly. Okay? And they don't all come from kimberlite pipes. Kimberlite pipes are a surface phenomenon, and they have little tiny, usually clear diamonds. This is a not so little tiny red diamond. It's a nice one. Now, let me clean the lens just in case. Oh, hey, Nani. I have not even touched this one. It was in the wrapper when I opened it, and I'm gonna not get my fingerprints on it. It is absolutely spectacular. Look at this thing, man. It's got dust on it. One of those things diamonds do, and you can take a little tiny diamond, you know, the De Beers kind. You put your finger underneath of it, and it looks like it fills up the inside of the stone. See what I mean? This one's a little bigger than that, and so you have to use more than one finger to make it fill it up. But that's one of the ways you can tell real quick and easy. The other way is diamonds sparkle around the periphery because they have all the little carbon atoms are now it has hemp seed oil on it, like all of my diamonds. Okay, the ignoring the hemp seed oil, the sparkles around the periphery are because all those carbon atoms line up in perfect rows and columns because they're all the same size. And we cut them with the planes of cleavage, with those rows and columns parallel to this line right here. Right? This is called the pavilion. And they open outwards so that a diamond catches the light. And that's why they sparkle around the periphery, because those planes of cleavage act as a waveguide, and the light goes bouncing around in there, but it follows those planes of cleavage out to the sides. Also, of course, carbon has carbon 14 in it, and so the really bright spots are the emissions, the beta emissions of carbon 14. The laser light from my video camera here is stimulating the emission of electrons from the extra neutron in carbon 14. Okay, and it's not something that I like made up, right? It's simple physics. And carbon 14 is present in all carbon. It's present in our body. And if you put a laser against your skin. Put a red laser against your skin, and the red light extends out into your skin on either side, even though that little sharp pointy line is only going straight down. And that's because the carbon-14 in our skin is stimulated to emit electrons at the exact same wavelength as the light that stimulates it. So in this case, it's red because all of the light is traveling along those little planes of cleavage. The stone itself is clear. The planes of cleavage are half the size of this particular shade of red. Somewhere around 700 nanometers is what red is. Right? That's the end, the large end of the visible spectrum. Blue is the narrow side, and the half the size means that if I've got a plane of cleavage and the light comes down and it bounces and it goes back up, it has then traveled one wavelength of visible light, and that's how it turns white light into red light. And that's why this looks so very, very bright, because it's all turned into red light. All of the white light, all of those different colors are joined together into one single wavelength of red light. And it's coming out on the sides, sparkling out the sides. So, and diamonds are not particularly heavy per weight, per unit of volume. Per weight to volume ratio is pretty low. And in fact, it's lighter than aluminum. When I have the same amount of aluminum, they're about equal, actually, because diamond is so very, very dense. But it's not heavy like rubies. Okay, if I have rubies that are almost this big, and they're heavy. You pick them up and you go, whoa, man. And a ruby this big would get somebody's attention if you whacked them on the head or something. Definitely. This one gets people's attention just because it's so beautiful. And, you know, it's doubly cool because I got two of them. Far out, huh? Yeah.